Hello everyone, welcome back to my channel. So in this video we'll be discussing about semaphore. So before moving on to semaphore, let's discuss what is the problem with the lock system that we had to move to semaphore. So basically, if one particular process has acquired the lock and it has its critical section running, then the others are in an infinite loop that is still running. It's not that the processes are put to sleep or they are not executing anything. They are still in an infinite loop. So that is, the process has to wait for a very long. Now it might also happen, the second demerit that is of locks is that it might happen that one particular process is continuously using the critical section, continuously acquired the lock and it's executing it again and again, and the others are not getting a chance. So there is no chance that the others get this execution done. So the third point that comes, which is a demerit of locks, is that we cannot do sequential execution in that. So if we want that the lock should be first acquired by a particular process and then by some other process and then by some other process, so we cannot do that there. So what we basically do is implement semaphore. Now in semaphore we have two functions, wait and signal, and for this semaphore is a concept that is a bit difficult to understand, so I saw an easy way of understanding semaphore on Geeks for Geeks, which was by restroom analogy. So what it says is that, for example, we have 3 restrooms and we have one security guard. So basically the security guard would be our semaphore, and then we have a queue of people who want to use the restroom. So what basically happens is that when we have this, we have the count is equal to 3. That is the number of restrooms available to us. So when this first person comes, P1, let's mention them P1, P2, P3, P4, P5 and P6. So when the first person comes, this security guard checks that yes, the count is 3. So it sends this person to one of the restrooms. So this person is in one of the restroom. So now this person is not here anymore. It's here. So P1 is in this restroom. Then we have the count reduced to 2. First of all, basically what it does is first it reduces the count. So count becomes 2 and then it checks if this is not negative. So since this was not negative, so it sent the first person to the restroom. Now second person comes and now it again reduces the count and then the count becomes 1. So it's still not negative. So it sends this person also to the restroom. So now P2 is in the restroom. Then third person comes, then again it will reduce the count, so the count becomes 0. So the count is still not negative. So what it will do, it will send this person also to restroom. Now when P4 or the fourth person comes, so what will happen, that this count will go to -1 and this is now negative. So when the count goes to negative, what it does is that it sends this person to a queue. It's basically, let's say that the security guard told the person to go and sleep at his home and he will wake him up when the restroom is empty. So P4 comes to this queue. Now what happens then? Then P5 comes. Then again this count becomes -2. So what happens? It will send P5 also to this queue. Now let's say after this, person P1 or let's say person P3 leaves the restroom. So what happens? This restroom is now empty and now it gives signal, because of which this count increments. So now it becomes -1. So not just the count increments when this person gave signal, the security guard will wake up the first person in the queue and call him to use the restroom. So now what will happen is that the person P4 would come to this restroom. So this queue becomes empty here. Now P5 is in the lead. Now if P6 comes, then again it will decrement, or if before P6 comes some other leave the restroom, then it will decrement, or sorry, then it will increment the count. So that ways it will run. And now we can see through these codes, it is now easy to understand it after we have seen the restroom example. So basically this problem that we have solved here is that we saw that, okay, first of all, so the problem that we solved here was of that if people are waiting for so long, it will basically put the process to sleep rather than telling it to execute an infinite loop. So now let's see through this example, like through the pseudocode. This is the pseudocode for semaphore. So the structure of semaphore is something like this, like it has a count variable and it has a queue. So the count variable that we discussed, that the security guard was increasing or decreasing, and the queue which he set the people to sleep, then that's the queue about which we're talking. So now after we've seen that example, we can easily understand this code. So count is being decreased, and if it's negative, it adds the caller process P to queue, the queue, because it's become because the count has become negative. So if the count is negative, then it means that all the restrooms in that analogy were occupied. So you need to send it to the queue, and then you also make the process P sleep. Then we see the signal is where they have used the restroom and they're moving out. So the count is incremented, and if the count is still negative, then it will remove a process P from queue. That is, we saw that when one of the restrooms were vacated, it woke up P4 to come. So you basically wake up the process P. So that's the simple implementation of semaphore. But initially the concept of semaphore was given by Dijkstra. So let's see the implementation that Dijkstra gave for semaphore, and we'll also see that what was the problem with that implementation, that we had to move on to this implementation of semaphore. So basically it was a very simple approach where we have a function P where while s equals 0, we run an infinite loop, and then s is equal to s minus 1, and then we have a function V where we do simply s is equal to s plus 1, and this is basically the wait function, and this is basically the signal function. So now what is the basic problem with this implementation? This was the implementation given by Dijkstra. So what is the basic problem with this is that here we can see that the loop keeps running. So basically we haven't put that process to sleep. So that's the problem that's occurred here. And another one is that bounded waiting issue, which we saw that if one has acquired the lock, then it's using it continuously, and some are not getting chance, or a lot of others are using it and one particular is not getting the chance. So that's what the problem with this implementation was. So we had to move on to the implementation that we just saw. So that's all about semaphore. We'll meet in the next video with a new topic.